So suppose that you're mowing a lawn, and each time you mow the lawn, you get paid $2 more than you did before. So this says when you mow the lawn the first time, you make $6. You mow the lawn second time, you get $8. You mow the lawn the third time, you get $10. This is a linear equation. And the linear equation would be y equals $2 per increase plus, is it 4 or 6? It's plus 4 because I need to backtrack to a sub 0. So this is plus 4. Now that's a little bit tricky, and you might ask, well, why didn't I start at a sub 0? And the reason is because today we're going to learn another equation that a sub 0 doesn't work very well. A sub 1 works really well. So, what does this equation tell me? What does it represent? So if I plugged in 10, x equals 10, 2 times 10 is 20 plus 4, y equals 24. What is this number? Careful. How much he earns on week 10. Okay? It doesn't tell me the total amount. All it tells me is how much that 1 week paid. Okay? Another way we could write this is a sub n equals a sub n minus 1 plus 2. And we also have to state the beginning, which is a sub 1 equals 6. That's the recursive formula. Okay? What if I wanted to know the total amount? How much, what is the total after 3 weeks? How would I figure that out? 6 plus 8 is 14 plus 10 is 24. So the total amount after 3 weeks is 24. Now, of course, that's assuming that he didn't mow the lawn in week 0. But everything we're going to do today starts with a sub 1. So it's kind of a switch from what we used to like. When we're doing linear equations, we like a sub 0 because that's the y-intercept, the b value. But now that we moved into sequences, we don't like a sub 0 so much. A sub 1 makes more sense. So it's kind of a rough transition. So what we do is we create what is called a series. A series is just the sum of a sequence. So in this case, the sequence is how much he gets paid each week, whoever this guy is. The series would be the total amount paid up to a particular point. And for a series, we don't use A's, we use S's. So S sub 1 is the total amount he made on week 1, which is 6. Sorry. S sub 2 is the total amount he's made up to week 2, which would be week 1 plus week 2, which is 6 plus 8, so it's 14. Okay? S sub 3 is going to be 24. What would S sub 4 be? So it would be 6 plus 8 plus 10 plus 12. So we have 36. Okay? Now, there is a way to represent the sum of a sequence. And it's a little bit strange, but it's very easy to figure out. What you need is the explicit formula and then what we call a summation machine. So you know when you watch some kind of show with a fraternity or sorority and they say my fraternity is Alpha Gamma Pi or whatever. They're just Greek letters. Well, in Greek letters, they have a letter called sigma. And capital sigma looks like this. It looks like an E, kind of. Or sometimes they write it like this. Okay? So In mathematics, capital sigma stands for summation, and a sum is the answer to an addition problem. So what this says is, I'm going to add up all of the values of a particular sequence. And the variables change from one to another. So we'll call this one k. So I'm going to add up the equation 2k plus 4, and I'm going to begin at k equals 1, because that's a sub 1. And everything we do today will start at 1. And then they write a number up here which tells you where to stop. So I could say 5. So all that means is I'm going to add up all of the terms of the sequence 2k plus 4, beginning with 1 and ending with 5. So S sub k equal, well, S sub n, I guess it is, because this is the n value. S sub n is the summation of the function from this number to that number. So let's try one. So if I had summation from k equals 1 up to 5 of 3k minus 4. How would I figure that out? Well, I plug in 1. What do I get when I plug in 1? Negative 1. Comma, what do I get when I plug in 2? Oh, and it's not comma. If it's comma, that's a sequence, but we're doing the series. So plus 3 or 6 minus 4 is 2. Plus, I did it again, sorry. Plus 5, plus, plug in 4. 12 minus 4 is 8. Plug in 5. 15 minus 4 is 11. So now I have to add all those together. So that's 19 plus 5 is 24, plus 2 is 26, minus 1. Wait, 27. Did I do that wrong? So 20. All right, I don't trust myself. Okay, 25. All right, that's super annoying, right? Especially, what if I changed my n value to 25? That's going to take forever. Well, if it's an arithmetic sequence, which creates an arithmetic series, there is a formula for S of n. So here's the formula. S sub n equals, and this only works if your sequence starts at 1. If your sequence starts at 0, you have to alter the equation, and it's kind of a pain, so we just never do that. So we always start. If it's a sub 0, what you would do is go through and change all of your numbers. You change the 0 to a 1 and the 1 to a 2. So you'd add 1 to all of your n values, and then you would alter, then you would subtract off what you need here. So if it starts at a sub 0, I would turn it into a sub 1, and then I would subtract 3 from that, so it would be 3k minus 7. And then I would use the formula I'm about to give you. But that's not going to happen. Okay? So it's kind of a mess, which is why we just don't do it. So S of n equals n times a sub 1 plus a sub n over 2. That is the formula for the summation from k equals 1 up to n. All right? So let's talk about this. What does this tell me? Where does that number come from? What's that? It's the top of the summation problem, or it's the subscript of the biggest term. So if I go back to here, if that's my biggest term, that's n. Whatever the subscript on your biggest term is, that's n. Okay? What is a sub 1? What does that represent? Not what's the number, but what does that represent? the value at 1. That's a good way to say it. The first number in the sequence, not the subscript, but the actual number in the sequence. Good? What's a sub n? It's the value of the last term. So don't get these two mixed up. This is the number of the last term, and this is the value of the last term. So does this number represent m, n, or a sub n? That's a sub n. What is n in this case? 1, 2, 3, 4, 5, fifth term. So this is the number of the term, and this is the value of the last term, and then divide it by 2. So let's try it here. So if I wanted to plug all that in to the formula, what is my n value here? What's the subscript on my biggest term? 25. 25 times my first term. How do I figure out my first term? I plug 1 in there. So 3 times 1 is 3, minus 4 is negative 1, which I already knew because it was right here. And I'm going to add that to the value of my last term. So now I'm going to plug 25 into this formula. 75 minus 4 is 71, and then I cut that in half. So 25 times 70 divided by 2. So in this case, S sub 25 equals 875. Now again, this formula only works if there's a common difference, if it's linear, if it's an arithmetic sequence. Okay? Well, an arithmetic sequence which creates an arithmetic series, so yeah. And it also only works if you begin at a sub 1. If you begin at a sub 0, then you have to make some changes, but that's not going to happen today. We've kind of dropped a sub 0 and thrown it away, and we're not going to do it again. Okay? At least not today or tomorrow. All right. So take a look at your worksheet. How are we going to find the value of the series with those given sequences? Just add them all together. Okay? So look at number 5. How are we going to find the value of that series? Use the formula. N times a sub 1 plus a sub n over 2. What is n? 35? So 35 times, what's a sub 1? So we plug in 1. 5 times 1 minus 2 is 3. Plus, what is a sub n? And how'd you get 173? I'm going to plug this in here. So that's 5 times 35 is 175 minus 2 is 173. And then I'm going to cut that in half. So 35 times 176 divided by 2. Did I mess up? Okay, 3080. All right, look at number 11. So I need to know the formula n times a sub 1 plus a sub n over 2. What do I not know? Is there anything I don't have? It's all there. It told me the first term, it told me the nth term, and it told me that the nth term is the 14th term. Now, we don't know how fast it's growing. Does that matter? No. We know it's arithmetic, though, okay, because it says evaluate each arithmetic series. So even though we don't know how much it's gaining, that doesn't matter in the formula. Because it's arithmetic, the formula will automatically work. Okay, turn the page. Take a look at number 15. So what do I not know in this formula? Do I know a sub 1? Yes. A sub 1 is 20. Okay. Do I know n? It told me n is 16. So 16 times 20. Do I know a sub n? No. How would I find a sub n? You could, what is the pattern? So I could do 20 plus 7. That's 1. This is 2 plus 7, 3, 4, 5. I could do that. That's a pain in the butt, and chances are you're going to make a mistake. How else could you find it? So the equation is going to be y equals 4, no, not 4, sorry. The equation is 7x plus, careful. Does everybody know why it's 13? You have to start this equation at 0. So 20 is my a sub 1, so my a sub 0 is 13. So plus 13. Now how do I find a sub n? Plug 16 in there. So 7. Good job. I'm impressed, Sadie. 7 times 16 plus 13. Now I have that. So now this is 125 over 2. And that will give me the summation. Well, there are two ways. We could have done the plus 7, plus 7, plus 7. Or you create the formula and then find it. All right. Look at 19. Determine the number of terms n in each arithmetic series. So it says I start at 1, and my first term is 19. My nth term is 96. How many terms are there? What number of term is it? Is it the 8th term or the 9th term or the 10th term? If the summation is 690. How are we going to figure that out? Good. We want to use the S of n formula. S of n equals n times a sub 1 plus a sub n over 2. Is there anything in this group that I do not know? I don't know n. Do I know everything else? Well, then we just use algebra. There are 4 variables. They told us 3 of them. So we plug in the 3 we know, and then we work backwards to find the one that's unknown. So 690 equals n is unknown times 19 plus 96 over 2. So 19 plus 96 is 115 divided by 2 is 57.5. Then what do I do? So, well, I already divided by 2. You might have done it differently. So did you times by 2 and then divide by this? Either way it'll work. So I'm going to divide by 57.5. So 690 divided by the answer is 12. What does that mean? And what does n equals 12 mean? It's telling me that 96 is the 12th term. Okay, we just wanted to know how many terms were there. Okay? Look at number 23. Do you understand what that says? D is not n, it's the common difference. So in our equation, mx plus b, that is m, meaning we're going up by 2 every time. Yeah, I'll help you. So I know my first term is negative 3. I know my common difference is 2, and I know that my summation is 21. So how am I going to figure out how many terms it's going to take? Well, my equation is y equals 2x plus negative 5. How'd you get negative 5? So I have a sub 1, and I need to go backwards a year, and I'm gaining $2 a year, so this is a negative 5. Okay, how does that help? Plug in the x. Which x? Oh, so we could, okay. So negative 3, plug in 2, and you get negative 1. Plug in 2, and you get 1. Or, plug in 3. Plug in 4, and you're going to get 3. When do I stop? Not, well, kind of at 21. When the sum is 21, right? Not when it equals 21. So these kind of cancel. The next one is 5. The next one is 7. How high am I? I'm up to 12 plus 9, 21. So what's my answer? Not 9. What am I looking for? The number of terms. So 1, 2, 3, 4, 5, 6, 7th term. Okay. Is there a way to do it without writing them all out? Because the next one goes up to 228. Does anybody see a way? Do you see a way to calculate a sub n? Well, let's try what we did last time. 21 equals n times negative 3 plus a sub n over 2. Well, that's kind of a problem. But what does a sub n equal? How would we calculate a sub n if I knew what n was? If n equaled 6, where would I plug in 6? I would plug it in here for the x. So what if I just went like this? A sub n is just 2 times n minus 5. Is this a little much? Okay, we'll stop it here. We'll talk about 23 and 24 tomorrow. Did you create a quadratic? I'll take a look. So your homework today is to go all the way to 22.